Okay, so on your video, today I don't have the answers right away. I'm going to work out each problem. So if you already have the problems done, which you should, you can fast forward until you see the whole page zoomed out and you can look at the answers. And then if you have any wrong, I would just rewind and find the spot that you need to watch specifically for the problems maybe that you missed. All right, so this whole first page are inequalities, and I know that because I don't have equal signs. I have these greater than or less than symbols. So everything on this first page is going to be a question of, is it solid or dashed, and is it shaded above or below? So let's go ahead and start with the first problem. Remember, I always answer that question for myself before I start, and I like to circle or put a box around whatever's in the y also. So because y has a negative number in front of it, this symbol is going to end up flipping around, which means this is going to be a dashed line, and it's going to be shaded above because it's greater than. So dashed because it doesn't have the line underneath, and above because it's greater than. And then this equation is actually in standard form, and it's really easy to do intercepts. So if I set up my two equations, and I just set them up like equations, but you can do inequalities if you want to. That's going to give me x equals 2 and negative 2y equals 2. So when I divide for y, I'm going to get y equals negative 1. So I've got my two values, x is 2, y is at negative 1. And this is going to be a dashed line, so you may end up using a ruler tomorrow. We're going to make it look dashed. And then we need to shade above, so I'm just going to shade in above. All right, I'm going to start question 2 the same way. Go ahead and look at my y value. It's positive, so the symbol's not going to flip around. So this time it has the line underneath, which makes it solid. It's still greater than, which means this one is also going to be above. Set up my two equations again for standard form, 6x equals negative 3. And if I do that, I'm actually noticing if I divide by 6, that's going to give me a fraction. So instead of dividing by 6, I think I'm going to work this one out and turn it into slope-intercept form. That's going to give me y is greater than or equal to. I can move the 6x over by subtracting it, so negative 6x minus 3. All right, now I'm going to start at negative 3, and negative 6x tells me I need to go down 6 and to the right 1. Well, I don't really have room to go down 6. That like runs me off the graph. So instead, I'm going to go up 6 and to the left 1. That's going to keep that negative slope. Now this time I'm going to do a solid line because that's what I told myself. And above. And remember, if you aren't sure where above is, you can put your pencil on your line, anywhere on your line, and just draw arrows straight up. And that will kind of give you a hint that above is going to be the side that you just drew lines on. That's the side you're going to shade. All right, question 3. This question, remember, some of you have been seeing these this week, and you're being silly because you know how to graph these. This is y equals negative 2, which is a line that's going to go through the y-axis. And I already broke my rule. My rule is the very first thing I should do always is say solid or dashed, above or below. You may even on your test tomorrow do that, like go through the entire test and write yourself notes, solid, dashed, above or below on everything before you start. That way you're not going to make mistakes as you go. So this one is going to be dashed because there's no line underneath, and then it's below because that says less than. So again, y equals negative 2 is a line that goes through 2 on the y-axis, so this is going to be a dashed line through 2. And then I want to shade below, which is pretty easy to figure out. All right, question 4. Again, this is going to be solid. And this time we're below because it says less than. Starting at positive 3. And then it says negative 4 over 5. We're going to put that negative on either the 4 or the 5, but not both. So I'm going to go down 4, 1, 2, 3, 4, and to the right 5. And if I had room, I would go up 4 and backwards 5. That's just kind of off the graph there. Now I'm just following the directions I wrote for myself. Make a solid line and shade it below. All right, and then make sure it's not going to be perfect, but make sure I know that you're intending that whole section to be shaded. Question 5. Some of you also looked at this one and were quite confused, but remember, if a y and an x are in both of the equations, and here I am breaking my rule again. First thing, pull it together, Miss Williams. First thing is to say that this is dashed and above. Okay, back to what I was saying a second ago. Since there's an x and a y, this is not going to be a line that cuts straight through the y-axis or straight up and down through the x-axis. This is actually y equals mx plus b. So hopefully you remember or are starting to realize that means this is y equals 1x plus 0. So I'm going to start at 0, up 1 over 1. Remember, we want to go all the way through the graph so that when we shade, you're shading like half the graph. And then we want to make, let's see, this is dashed, so make sure you make it look dashed, and then shading above. All right, question 6. Now this one just has an x in it, which means we are going to cut through the x-axis. Again, breaking my rules, do as I say, not as I do. This is going to be dashed and above because it says greater than. So this is going to cut through the x-axis at -2. And we want to do above, oh, what am I saying? Cut through the x-axis at -2. Now, some of you get confused here when this says above and there is no above. So then you need to go back to the drawing board and kind of think about, if x is greater, which side do you think that should be on? Well, the greater side for x is going to be on the right side. So remember, if x is greater, we go to the right. If x is less than, so if x is greater, you're going to go to the right. If x is less than, you would have shaded over here on the left side. All right, so like I told you, here are your answers for this page. If there are any that you need to, if you're just now checking your answers and you need to see the explanations for any of them, rewind and go find the problem that I did. All right, let's move on to the next page. Okay, so questions 7 and 8 are a little different. They're actually giving us the graph and asking us to write an inequality. So just the same way on the last ones that I said we needed to determine solid or dashed above or below first, I'm going to use that to pick my symbol before I write my equation. So looking at this, I know that this is a dashed line, which means it can either be greater than or less than with no equal sign. And now I'm shading below, which means I want to pick the less than symbol. So whatever equation I write, it's going to have that symbol, or inequality rather. Now this line is cutting only through the y-axis, and it's hitting the y-axis at +3. So the equation here is going to be y is less than 3. All right, similar start for question 8. I want to think about my symbols. This is a solid line, which is going to be greater than or equal to or less than or equal to. And again, I'm shading, well, not again, but in this question, I'm shading above, right? All of this is shaded above the line, so that's going to be greater than or equal to. Now this time, the easiest way to do this is to write my equation in y equals mx plus b. So I'm starting at 5, and I notice if I find more points on my line, I can count this slope is -3 over 1. All right, that means this is going to be y is greater than or equal to, right? That's the symbol I just picked. -3 over 1x, or you could just say -3 plus 5, because I started at 5. All right, make sure you know how to do questions like that for tomorrow. Questions 9 through 12. So now we're getting to a section where we're graphing, and notice this is not quite like what we learned today. These are just equal signs, which means we're just looking for a single point where they're going to hit each other because there's no shading involved in these. So let's go ahead and start on this first problem, and I hope that you recognize something special about this first problem. Hopefully you recognize that these have the same slopes. And you remember that means the lines are going to be, think about it, parallel. And because they're parallel, it means we should be getting no solution. But even if you know that this is no solution on your test tomorrow, what I would like for you to do is to still graph the lines to show that. So I'm going to graph the first one. I'm going to start at +4, and then my slope is 2 over 1, so up 2 to the right 1. I don't really have room to do that, so I'm going to go down 2 and to the left 1. Since this is an equal sign, again, there's no shading. I'm just going to make a connected line through there. And I'll do my second line, and this time I'm starting at -2, -1, and then going up 2 over 1, down 2 to the left 1. Make sure you make points going all the way through your graph. And indeed, these are parallel lines that do not intersect, so I'm going to write no solution as my final answer there. All right, question 10. The first line is in standard form, and both of those have 1s in front of them, so that's an easy thing to graph with intercepts. So if I do that, I'm going to get x is -4 and y is -4 when I set up my two equations. I can go ahead and connect those to make my line. All right, and then my second equation says x equals -2. That's just a straight line that cuts through the x-axis at -2. So I'm going to graph it. And remember, I'm looking for where these intersect each other. And so if I found that point, and that is at -2, -2. This is an example of one solution. Remember, you can also take this value, this x and y, and plug them back in if you want to check and make sure that they're right. There shouldn't be any question on your test tomorrow that you really don't know if you're right or not. All right, let's look at question 11. So the first equation here in question 11 is not really set up very well. This is not in standard form. I can try to move the 2 over, but that won't fix it. So I'm just going to change this to slope-intercept. So that's going to become y equals, when I move the 5x over, it's going to become -5x. When I move the -2 over, it's going to become +2. So I'm going to start at 2, go down 5, and to the right 1. Connect these. All right, and then the other equation, now the second equation is in standard form, and it is pretty easy to graph using those x and y intercepts. That's at -2, +2. And then make sure you use a ruler tomorrow so we get good straight lines. Those are crossing here at this point 1, -3. So my solution, my one solution, is at 1, -3. So that's the answer, the 1, -3. That's what you're going to have to make sure you write for tomorrow. All right, question 12, last one on this page. This first equation is written kind of strange. It's definitely not in standard form, but it is pretty close to being in slope-intercept. The only thing I have left to do is divide by 2 so that y is by itself. So when I do that, I'm going to get y equals, if I divide everything by 2, that's going to give me 3 over 2x plus 2. So I'm going to start at +2 and then go up 3 and to the right 2, down 3 and to the left 2, and I'm going to continue that pattern as long as I have room on my graph. Connect my line. All right, and then the second equation, that's kind of a weird one. That's not standard form or anything else either. So I think I'm just going to try to get slope-intercept form or get y by itself again. And when I do that, I'm going to get y equals -4. So that's just a line that cuts through the y-axis at -4. So I'm going to make a completely horizontal line here at -4 on the y-axis. And that's going to give me my solution. I see I've got one solution here that's at -4, -4. Again, like I've said, we can take this value and plug in -4 for the x and -4 for the y in both of my original equations and make sure that that actually works. And it should when we plug that in. All right, so again, here is that entire page of answers. If you missed any of those, go back and watch the video. Make sure you see what it is you did wrong, and just be very cautious that you don't make those same mistakes tomorrow. All right, we're on to page 3. I do know that in one of your classes they already say skip, but we did skip questions 14 and 15. All right, so let's go ahead and work out some of these. Question 13 says, which of the following systems has no solution? You all have been pretty good at this. You know no solution is when they have the same slope. Now some of you know really well, okay, C and B, those are both one solution. We don't need to worry about that. Sometimes people get tripped up on this because they say, well, can there be more than one answer? You know, A has the same slope and so does D. But look very carefully at those. D is the exact same equation. So D is actually an example of infinite solutions because that's the exact same line twice. This is asking for no solution where they're not going to intersect at all. So A is my example of no solution, and it does say explain, which you're going to have to do on your test tomorrow, and really you just need to say something to the effect of same slopes. So this is what I'm going to write. Same slopes mean parallel lines. Because I know that parallel lines mean they're not going to intersect. Okay? Again, we skipped 14 and 15. So then let's go ahead and look at 16 here. And some of you were like, I don't know how to do 16. We're going to have to solve that out. Remember, we did that one set of problems together in your calculator where I showed you that you could just plug in X and Y and check to see when the solution worked. So if I look at 16 here, this is really easy because 6 is X and the Y value. So when I plug that in, for example, on A, I'm going to be saying like 3 times 6 plus 4 times 6, does that equal 0? Well, even if you don't know what that equals, that definitely does not equal 0. So if it fails in the first equation, it's not going to be anything in that because remember, it needs to work for both. So if I go ahead and try B here, 4 times 6, I'm just going to multiply that, is 24, minus 3 times 6, which is 18. That is 6. Okay, so it works in the first equation. And then negative 12. You have a calculator to do this. I don't. I'm being lazy because I don't want to get a calculator. Negative 12 plus 6. Well, that is definitely not negative 3. Negative 12 plus 6 is negative 6, so it does not work in that one. So it's not B either. All right, question C, I'm going to go ahead and plug in 6. So that's going to give me 18 plus 6, which is 24, not 4. So definitely not option C. So it must be D. However, I'm going to check it anyway just to make sure I didn't make a mistake somewhere else. So 6 plus 6 equals 12. All right, that one works. If I plug in 6's for the second one, that gives me 18 minus 12, which is 6. So D is my answer here. That's the equation that gives me the solution 6, 6. All right, 17, I have a feeling a lot of you are going to want help on 17. I think that you know how to do part of it. You're maybe just a little confused on the second part. Now, the directions are very important, and they give you some hints. It says to write a system. All right, that means I'm going to be writing 2 inequalities. So I need to be using my inequality symbols. Now, I think the first one you can get down. It says no more than 530. Uniforms are $45 each. Bats are $22 each. Okay, so if I write that, I think most of you are going to get 45x because each, those are rate words. So 45x plus 22y. And then no more than, so if it's not more, that means it must be less than or equal to 530. Now let me give you some advice. I think that you should always put the total here at the end. It's going to make sure that you don't do something silly with this symbol. And then we need to go ahead and define what these variables are. So we said X, $45 each, that was for uniforms. And then Y is for bats. So now, let's think about maybe how we would write the second equation. So the second part says the coach needs to buy at least 15 pieces of equipment. At least 15 pieces. So what are the 2 pieces of equipment that the coach could buy? Well, the coach could buy uniforms, which are X, or they may buy some bats, or both, right? So plus the number of bats plus Y is at least 15. That means it is greater than or equal to 15. Okay? Now, we did talk about this the other day, that it would be very difficult for us to solve this and create a slope, particularly on this first one, because our slope would be something crazy, like down 22 over 45. That would just be really annoying. So instead of doing that, I'm going to treat this first one as if the numbers were divisible and I could do intercepts. So when I do that, that's going to give me 45x is less than or equal to 530, and 22y is less than or equal to 530. And here I go breaking my rules again. What did I tell us? Anytime you have inequalities, go ahead and label what you're going to do. This is going to be solid and below. Okay, so let's try this. If I divide by 45, on this first one, I'm going to get the x-intercept is somewhere around, let's see, what was it, 11.77 or 11.8. On the y-intercept, if I divide by 22, I'm going to get the y-intercept is somewhere around 24.1. So when I'm graphing these, it's not going to be perfect, but I'm just going to get it as close as I can. So we do need to label our x and y axis. All right, our x-axis is uniforms. Our y-axis is going to be bats. So we said that the x point needs to be at 11.8. Let's see, 11.8. I'm just going to make that as close, kind of close to 12. This is not perfect. And then our y-intercept is somewhere around 24. So I'm just going to make that as close as I can to 24. This is supposed to be a solid line. And I'm supposed to be shading, what did we say? Shading below. All right, so I'm going to shade in this lower region here. All right, now, my second equation is a little bit easier when it comes to solving for intercepts because I don't really have to worry about dividing. My two intercepts here, let me get my pen back out. My two intercepts here are going to be x at 15 and then y at 15. And we should state what this symbol tells us to do, and that is I should be solid, and this time above. All right, so I'm going to do make a point at 15 on the x-axis and 15 on the y-axis. I'm going to connect these with a solid line, and this time I'm going to shade above, which is going to be this whole section. And remember, with systems of inequalities, we're looking for the area that overlap. So I'm going to zoom in for us real quick. It says name one solution and name one non-solution. So remember, solutions are in this double shaded area. So I'm looking for something in that area. Probably it's something that would be easy to name. So I think this 216 right here, that looks like a pretty good solution. It's in that double area. There's no question that it's in there. So 216 is going to be my solution. And that means 2 uniforms and 16 bats. And then we'll say our non-solution. There are really a lot of non-solutions to choose from. I'm just going to pick something way over here. It would be impossible to meet the qualifications and to get 20 uniforms and 12 bats. That's not going to work for this problem because it's not in the double shaded region. All right, so on this page, so some of you are just now checking your answers to see what it is you need to watch. Rewatch what you need to. Make sure that you understand the explanations and maybe how to work most of the problems on this page. We will work a little bit more on 17 tomorrow if you need it, but you probably need to come to tutoring if you feel like you are very, very confused on 17. All right, our last page, thank goodness. So on question 18, it says, and I don't even know why those directions are there. Those are for problems that aren't in this set. Question 18 says select all of the following, which are solutions to the system of inequalities graphed below. So I'm just going to try to determine if these are solutions. Remember, solutions, again, are in the double shaded area. That's going to be this section right here. And they cannot be on this dashed line. Okay, so like 2, 0, 2, 0, that one works. 1, 1, that one works. And I guess I should probably circle these instead of checking them off. These work. 1, 1 does. If I graph 2, 3, 2, 3 is on a dashed line. That is not a solution. 0, 3 is not in the double shaded area. It's not a solution. 2, negative 1, That's on my solid line next to the double shaded area, so that one does work. -3, -2, that's on the dashed line, and it's not even at the double shaded area, so that does not work. 0, 0, same issue, not in the double shaded area. Now 0, 1 is kind of a question. So remember, I need it to be true for both cases. That's why the double shaded area works, because it's a solution for both things. 0, 1 is on a solid line, but it's also on a dashed line, which means it's not going to be true for one of the lines. So 0, 1 is not a solution, because it's, even though it's on a solid line, it's also on a dashed line. So it would need to be on both solid lines to count. All right, so let's look at question 19. Write the system of inequalities graphed below. This is a lot like those previous questions that we did. So the first thing we want to do is identify our inequality symbols. So I'm just gonna pick a line to start with. I'll pick this one. Gonna kind of wrap my arrow around. So I know that this is solid. That means I'm doing greater than or equal to or less than or equal to. And it's shaded above, so that means I've got to do greater than or equal to. So I'm going to find where I'm starting, which is at 0. And the slope here is down, it looks like it's down 2 over 1. Yep, that's right. So that's first equation is going to be y is greater than or equal to -2 over 1 x. You can put plus 0 if you want to. Okay, there is a simpler way to write that. You could just say y is greater than or equal to -2x. It's totally up to you as long as what you're writing is equivalent. All right, my second line, now because it says system, remember I've got to write 2. So this second inequality, I notice that that's a dashed line, so that's going to be either greater than or less than. Now I'm not shading above or below on it, but it does look like I'm shading to the right, which to me is a greater than direction, so I'm going to say that this is greater than. Now this time I'm not even crossing through the y-axis. This is a completely vertical line, which means it's an x line, and it's crossing through 1. So this is going to be x is greater than 1. So your solution, or your answer rather, to this question is this set of inequalities, right? These two inequalities. Okay, let's look at question 20. So question 20 and 21, we kind of worked on these today, just like I've said before. So I'm actually going to follow my advice this time. I'm going to go through and label each as solid or dashed, above or below, before I start. So like in question 20, I noticed that this is solid and below because it's less than or equal to. The other one is going to be dashed and below. All right, question 21. I have a negative y, so that's going to flip my symbol around, which means this one is going to be dashed and below because it's less than now. And on my second one, I've got a less than or equal to symbol. That's going to be solid and below. All right, I followed my own instructions this time. So let's look at question 20 specifically. I'm going to start with the first equation, start at 2, just like it says. Go down 3, so that's -3 over 2. We need to put the negative on one part of the equation, so I'm going to put it at the top, so down 3 over 2. Continue that pattern all the way through the graph, up 3 backwards 2. And now I'm going to use my cheats. I told myself that I was going to make this a solid line, and then I wanted to shade below. So I'm going to do that. All right, then I'm going to move to the second line. And the second line says start at -2 and do the same slope. So I am going to be getting parallel lines. You all were really good today, I think, at noticing that parallel lines, when you have inequalities, don't really mean a whole lot as far as solution or no solution. So this one is dashed. I'm going to make sure that I got a good dashed line going on here. And this time, I'm shading below again, so this side. And we just want to identify where my solution set is, and your solution is the double shaded region. So I'm just going to name that my solution is this whole kind of bottom corner down here. All right, let's look at question 21. This first equation is actually in a good format for y-intercepts. So that's going to be x is greater than -1, negative y is greater than -1. So x is greater than -1, that's already solved. So I'm going to put a point at -1 on the x-axis. For the y, I've got to divide by -1, so y gets to be by itself. So that's going to be y is less than, because remember it will flip, +1. All right, this is a dashed line. So this is where your ruler is really going to come in handy, so it becomes a really good straight line. And we've said to shade below, so I'm going to go ahead and do that. And then my second equation here, y is less than or equal to 2. All right, so that's just a line that cuts straight through the y-axis at 2, and it says solid, so I'm going to make that solid. And then they're telling me to shade, or I actually told myself rather to shade below, so I'm going to do that. And here I can tell my double shaded region is this bottom, let's see, this bottom right hand corner. So this whole kind of bottom section down here is the solution. Anything in that set is going to be my solution. All right, last question, question 22. This is quite a simple inequality. You may not realize it at first, but I think as soon as I start talking, it's going to make a lot of sense. It says, if I tell you this, and this may help, the x-axis is going to be the score, and the y-axis is going to be the family's income, which is going to be money, income. Okay, so if it says a student must score at least 75, that means x, which is the score, has to be at least, so that's greater than or equal to 75. All right, that in itself is its own line. So if I kind of pause for a second, this right here is a solid line, and because it's an x equals line, that's actually going to be ended up shading to the right because it's a greater than. So I'm going to make a solid line through 75, which is not going to be a perfect kind of spot, and I'm going to shade to the right. Okay, now on the second equation, it says the family must make less than $40,000 a year. So that's the income, that's how much they make, y, is less than $40,000 a year. All right, so that's, if I go back and make notes to myself, this is dashed and below. So now I'm just trying to graph that line. It's a y equals line, so I'm going to go through 40 on the y-axis, but I want to make it dashed. And I need to shade below. And I'm looking for that double shaded region, which hopefully you realize is this bottom kind of overlapping corner down here on the right. All right, so that is my solution set. And if we name one solution, so I'll zoom in here just so you and I are kind of looking at the same thing a little easier. One solution, anything in there really would work. So I'm going to say a 90 and 20,000. All right, that would be a solution because it's in this double shaded region. If I change that to, that's this orange point that I've made right here. A non-solution is obviously anything not in that double shaded region. So for my non-solution, I'm going to say, I could really pick anything. I'm going to pick this 40 and 10,000. That would be a non-solution. All right. Make sure, so let me zoom out so you can check everything. Make sure that you're good. The only two questions I think you're really going to need help with are 17 or 22. So if you're really feeling like you're struggling on more than just those two questions, you really probably need to plan to come in the morning and get some help with those. And make sure you're studying everything you need to as far as your notes tonight, so that when you come in, you've got really good specific questions tomorrow. All right.